All right, let's talk about databases. But you know what? Forget the dry technical manuals for a minute. Today, we're going to figure all this out by heading to a party. We're going to explore a really critical concept, database isolation levels, by hitting the dance floor. I know, it sounds a bit out there, but just stick with me on this one. Imagine your database is a packed dance floor on a Saturday night. Every single person trying to use it, every user, every process is a dancer. Some are doing their own thing, some are in a group, and they're all trying not to smash into each other. Well, the rules you set to stop the chaos, those are your database isolation levels.
So, here's our plan for the night. First, we'll get a feel for the dance floor and the problems that can pop up. Then, we're going to meet all the different dancers, the casual ones, the really serious performers, and even a time traveler. And by the end, you'll know exactly how to choose the right dance style for your own situation. So, any busy database has what I like to call the dance floor dilemma. You've got all these dancers, your transactions, trying to read and write data all at once. If you don't have any rules, it's a mess. You'll have one dancer stepping on someone's toes, another one seeing a half-finished move and copying it all wrong, or just getting totally confused when new people suddenly jump into their space. Isolation levels are basically the dance floor etiquette that keeps everything moving smoothly. Okay, let's start with the two most common styles you'll see on the floor. These are our casual dancers. Their main goal is to keep things moving fast, to keep the energy up. But as you'll see, that focus on speed sometimes means they're not always perfectly accurate. First up, we've got the risky reveller. This dancer has absolutely zero chill. They just jump right in and start copying whatever moves they see, even if the other dancer is just trying something out and hasn't perfected it yet. In database land, this is called a dirty read. You're basically reading data that hasn't been saved or committed, and there's a good chance it's going to change or even be erased completely. It is super fast, but wow, is it risky. So how do you actually tell your database to be this reckless? You use this line right here. Set transaction isolation level, read uncommitted. That's the instruction. It tells the database that for this dance, we care about speed more than anything. So when this select statement runs, it doesn't wait around for anyone. It just grabs the data as is, which is why it's so fast, and also why you might get the wrong information. Next up is the respectful observer. Now this dancer is a little more polite. They'll see someone working on a new move, but they'll actually wait on the sidelines until that other dancer has totally finished before they take a look. This completely avoids those dirty reads we just saw. This dancer only ever sees the final, saved, perfected version of the move. Now look at this code. It seems almost identical, right? But changing that one level to read committed makes a world of difference. Now, when our select statement goes to read the data, it'll actually pause if another transaction is in the middle of changing things. That tiny change guarantees we only read data that's been officially saved or committed. No more dirty reads. So here's the bottom line for these two. It's a classic trade-off. Read uncommitted is pure speed. You get an answer right now, but it could totally be the wrong answer. Read committed, on the other hand, makes you wait just a little bit, but guarantees the data you see is legit. It's actually the default setting for a lot of databases, and this speed versus safety dance is exactly why. Okay, let's leave the casual crowd and head over to the VIP section of the dance floor. This is where the serious performers hang out. These dancers aren't just trying to avoid seeing messy moves. They need to make sure the floor around them stays perfectly predictable for their entire performance. And that dedication to consistency,
Well, it comes at a cost.
Meet the dance floor guardian. This dancer takes things a step further. Once they've seen a set of moves they like, they basically put a velvet rope around those specific dancers. Nobody else is allowed to change the moves that our guardian has already read, not until the guardian's own transaction is completely finished. This gives them a powerful guarantee. If they look at the same data twice, it'll be absolutely identical. A repeatable read. And the secret weapon in the code here is something called locking. When you use repeatable read, your select statement is now doing double duty. It doesn't just read the data, it also places a temporary lock on the specific rows it just read. That lock means no other transaction can come in and change that data until our guardian is done and releases the lock. It's how the database enforces that repeatable read promise. And now for the highest level of protection, the true diva of the dance floor, the exclusive performer. This dancer doesn't just lock the other dancers they're watching. No, they lock down their entire section of the dance floor. Nobody can change any existing moves in that area, and just as important, no new dancers can even enter that area to start a new move. It's a total lockdown. So the serializable level cranks locking up to the max. It uses something called a range lock. This not only locks the rows that are already there, but it also prevents any new rows from being added that would fit into that range. This is how you stop a weird phenomenon called phantom reads. You know, where new dancers seem to just appear out of thin air in your section of the floor. This is the ultimate guarantee of a stable, unchanging view of the data. So let's put these two serious performers side by side. Think of it this way. Repeatable read is like a bodyguard for the specific dancers you're watching. Serializable is like hiring security for the entire VIP section. It protects the dancers who are already there, and it stops any new people from crashing the party. This provides the absolute highest level of consistency, making it seem like every transaction happened one after another perfectly in order, or serially. Okay, so we've met dancers who are risky, polite, and even downright controlling. But there is one more dancer, a very special one, who doesn't play by these rules of locking at all. This one has a completely different strategy for getting a perfect performance. Let me introduce you to the time-traveling dancer. When this dancer begins their routine, they take a mental picture, a snapshot of the entire dance floor. And for their whole performance, that's the only version of the dance floor they see. In the real world, other dancers can come and go, change their moves, do whatever they want. But our time traveler is dancing in their own private, consistent, frozen moment from the past. The absolute magic of snapshot isolation is that it achieves consistency without all that locking. See, when the transaction starts, the database literally makes a private copy of the data for it. So all of our select statements are reading from this personal, unchanging snapshot. This gives you amazing consistency without blocking other dancers, which makes it an incredibly powerful alternative. Wow, okay, we've met the whole cast of characters now. From the reckless to the respectful, the guardians to the time travelers. Now it is time to bring it all home and figure out which one of these dance styles is the right one for you. And this table just lays it all out perfectly. Up top, you've got the risky reveller. You get maximum concurrency, everyone can dance at once, but the consistency is terrible. As you move down the table to the observer, the guardian, and the performer, you gain more and more consistency, but you also introduce more locks, which can slow everyone else down. And then off to the side, you have the time traveler, giving you that high consistency with a totally different method. So if you take one thing away from all this, let it be this. There is no single best level. It's just not that simple. Choosing an isolation level is a massive design decision. Are you building a reporting dashboard where scene data that's a few seconds out of date is totally fine in exchange for speed? Recommitted is probably your jam. Are you processing a financial transaction where the numbers have to be perfect from start to finish? Well, then you need to bring in the serious performers like serializable or snapshot.
And that's really the question I want to leave you with. Think about your application, your data, as a dancer on this floor. Is it a high-energy, free-for-all party, or is it a perfectly choreographed, exclusive performance? Once you understand these different dance styles, you have the power to pick the right moves to make sure your database performs flawlessly without ever stepping on a single toe.